Good afternoon to all. Welcome again to our next session, session 2, which is about STEM education, robotics and coding. And I believe that you all have practiced all the circuits we have provided and we have shown you in our previous uh, session. And many of you have shown great dedication and interest in designing circuits and working on different components, but uh, still we need more enthusiasm, we need more we can say interest from your side, but no problem, it will take a little bit time. So now we are starting our next session, session 2, which as we have given you the content which will be based on Arduino boards and interfacing of components and basic about coding. So we'll start. I am here on Tinkercad. I have logged in. Then I move to circuits, and you can see that our first circuit is LED blinking. So I have opened the circuit. You also please log on to your Tinkercad and open the circuit. I am opening another window here. So here what you are seeing, you have one Arduino board. We have one resistance connected to Arduino board and one LED. Last time we have seen that what is LED? Light emitting diode, which need to be connected in a proper way. What is that proper way? We need to connect this cathode to negative and this anode to positive terminal of the batteries. So why we have shown you previous examples of circuitry, so that you get the idea how to connect components your uh, with your controller. So now we are working on Arduino boards, and maybe some of you haven't heard about Arduino boards. We'll discuss it, that too. So what you need to do, open your circuits, create a new design. I'm making this circuit here. You also start making this circuit. Then from the components, choose from the components, all the components, and then drag down, and you will find one board here with the name Arduino Uno. So this is the Arduino Uno board. I am selecting all and dragging down, and I'll try to find Arduino Uno. So this is my Arduino Uno. Next, what we need? We need one LED. So I'll take one LED here. Then we need one resistor. Why we use resistor? Why we use resistor? To limit the current. I told you that the LED which we are using here, it operates at 2.5 volt, and the battery which we were using in our previous session, that was 9 volt battery. So to reduce the potential, or you can say to limit the current, we were using resistor. So similarly, same thing we are going to do in this circuit also, but in place of our battery, who will be feeding the LED circuit? Our Arduino controller or Arduino board, or you can say the Arduino Uno board. So what we need to do? We need to connect this cathode to one end of the resistance, and another end of the resistance will be connected to ground. Now the second terminal, which is anode, I am going to connect it. Let me check that where I have connected it. I have connected it to pin number 13. So the second terminal, which is anode positive, is going to connect pin number 13 of Arduino board. Now this is my circuit. What I have done, instead of using a battery, now I am connecting the same circuit, LED with resistor, with Arduino controller. Now we'll see that is it working or not. I am pressing the start button and look, my LED is blinking with the speed or with the delay of 1 second. That means for 1 second it is glowing and for 1 second it is uh, make it is off. So it's on and off with an interval of 1 second. So on the right side you can see that we have few commands here. What are these commands? This is what visual programming. Instead of using the traditional code, I'm showing you the code also, traditional code also. So this is the traditional way of coding. So this is the code which is written in embedded C, where you have written a few instructions to run the LED in this particular way. That means we need to blink the LED with an interval of 1 second. So in this traditional coding, we have first assign one pin in setup, then we are running a loop. But for beginners, it is a little bit difficult to understand the traditional way of coding. That's why we move to block programming or visual programming. Now you can see the program is quite simple. What we have done here, we have taken first command to glow or to make LED high. High means to glow the LED. That means if it is high, then LED will glow, and if we are making it low, that means LED will not glow. And we are putting a delay. So what you are seeing here in the first instruction, we are making the LED high. Then we have put a command, a block of delay, where we have fixed 1 second delay. Then again we have used the same command to make the same LED low, and then we have used again a delay of 1 second. So this will keep on happening, until the Arduino, until the controller is powered. So by writing these two instructions with the delay instruction, we have programmed this Arduino board. So when I press the simulation button, you will find that our LED is blinking. One more thing is there, you can change the delay. Let's say you want to blink LED with an interval of half second. So make it half, and you will find that your LED will now blink with the rate of half second. You want to make it fast, make it 0.2, or you can say 200 millisecond, and you will find that now LED will blink at faster rate than previous cases. So this is how we are doing this. This is written here, set built-in LED to high. Actually what is there, that in Arduino pin number 13 is connected to internal LED. So let's say if we want to change it, we can change it. I am connecting it to pin number 8. I am connecting it to pin number 8. So now if it is pin number 8, then we need to change the programming. You can see here that we have few categories here: inputs and outputs, control, maths. Don't worry, you will get all of these categories one by one. Have patience. So what we need to do here, we need to have an input, one output command here. Instead of built-in, we will be using one set pin, and we'll delete this set built-in block code. This, instead of this, we are using now set pin. Now at which pin I have connected this LED to pin number 8. So from here you select the pin number 8. Then again we need to delete this block also. You can duplicate it. Sorry. Sorry. You can duplicate, actually it got duplicated. All this. I'm deleting this. So what we need? We need to now a delay of 0.2 second here. And again I'm using the same block to make the LED, so to make the pin number 8 but at low. So now instead of connecting our LED to pin number 13, I am connecting my LED to pin number 8. So I have connected it. Now let's check the program. So again the LED is blinking with a rate of 0.2 or 200 millisecond, but in this case we have connected our LED to pin number 8 of the Arduino board. Have you got it? Do you have any confusion? Write in comment section. Anything you want to ask at this particular moment related to this uh, interfacing project? What are you saying, Sanket? Yes. Please mark your attendance here also, and please, if possible, send a WhatsApp message also. We have provided you the WhatsApp number. Please mark the attendance on this chat session, in this chat section also, comment section, and send a WhatsApp message to the WhatsApp number also. If you have any confusion, please write here. Okay, no confusion. Okay. So you have got one thing, that instead of using a battery, automatically we are blinking one LED with the help of a controller. And that controller is Arduino controller. So many of you definitely will be having confusion here, because might be you don't know what is Arduino boards. You can see it here in our, it's on the screen, that what is Arduino? Arduino is actually a company, Italy company. They have designed controllers. Already they are controllers. But what they have done, they have, to make it easy for beginners, for DIY, do-it-yourself projects, for different applications, for making robots, for making your drones, everything, and to make it easy for you people, Arduino company has made it easy by designing these controllers, fitting all the things on a board. So controller is there. There is uh, there is a controller on the board, but apart from controller, they have given other facilities also, so that you can connect your controller easily using your USB with your computers. In the similar way, there are different things they have mounted on a board with a controller, and they have given a name, given a name Arduino board. But it's not a single board. There are varieties of board in Arduino family. As you are seeing on the board, on your screen, there is one board which is Arduino Lilypad. Another is Arduino Leonardo, Arduino Mega, Arduino Uno, Arduino Nano, and Arduino Mini. So based on the requirement, we choose these boards. Some have different inputs, outputs. Some have more analog inputs. Some have more digital inputs. So based on the requirement, we choose the boards from the market. We purchase them and use them according to our projects. What good thing is there, that Arduino has made things available to everybody. That means it is completely open source. You can use these boards anywhere, non-commercially or commercially, for your applications, for your projects, for your DIY projects. So you can make anything, any projects, possible projects, with the help of these Arduino boards. So what is Arduino? It is also mini computer, which is used to do small tasks, to design different projects. Then then comes, what is computer? It will take a little bit time then, but thing is that you will get familiar with the controller, that how a controller works and how it is similar to your computers. These are mini computers, as I told you. As you are seeing on the screen, we have two images here. On the left side, I have shown you a human body, and on the right side, I have shown you a computer. Now compare these two things. If we see human body, you can see that the human brain works as CPU, and there is memory also. So our brain is nothing but a computer which takes the input from different inputs from the body, and then based on the program which we learned from the environment, from our childhood age, from the time of our birth, we start learning. That means our brain get start programmed. So we learn from the environment, from language. Let's say we are from India, so we learn our local language, let's say Hindi, Marathi, Malayalam, Tamil, whatever language whatever environment we are living. So our brain starts get programming from the environment, and brain takes the inputs, and based on the program our body retaliates or reacts in the form of actions, different actions. So what are different inputs? What are different inputs in our body? Inputs are our eyes. Our eyes acts as a vision sensor. Our ears, they hear voice, then interpret it or find the meaning of that voice. Similarly, we have skin. So when we touch our skin, there is a pressure sensor over there, there is a heat sensor over there, there is a touch sensor over there. So everything is there. All the sensors are there in our body. We have a mouth, a tongue is there, which taste, which give a signal, input signal. When it tastes something, you taste something bitter or something sour, it gives the signal to the brain. In the same way, we have output devices. We have a mouth. I'm outputting the signal. My mouth is outputting a signal in the form of voice. In the same way, our body reacts, it outputs. Let's say we get some signal to move from one place to another place. So our body move, or that means the signal will be in the form of physical movement. So when our body sense the thing, they send the signal to the brain, and the brain, according to the program, then send the signal to the output devices. Then the output devices will be giving out the output. It may be the physical motion, it may be the voice, or it may be any signal. You can call somebody, hey, come here. You listen something and then say, hey, go away from here, don't come to me, or it's dangerous here. So what is these things happening here? Our inputs are sending signal to the brain, where we have a memory which have stored a program which we have learned from our understanding, from the environment, from our parents, from our teachers, from our schools, and then we retaliate in us according to the program. Now comes to the computer. God is the biggest scientist in the world. Keep this in mind. Who is the biggest scientist? God. Whatever devices, whatever technologies, whatever discoveries we are doing, we are actually stealing different concepts from the nature. Already there things are there, or existing things are there, which we keep on stealing and use them in our technologies. So how computer has come into came in existence? Taken an example from human body, how human body behaves, works, or take the signals and output the signals based on the program. When we come to the computer, you all have seen computer. Many of you might be having your personal computer, your laptops, or different things in your houses, and you have used computers in your laboratories, in your schools. What are the main things you see in a computer? What is the main part which actually works to operate or to handle different things attached to it? That is CPU, Central Processing Unit. I have written in image brain as CPU. Central Processing Unit means which is centrally processing the devices. So we have input devices here. We have scanner, we have mouse, we have keyboard. And what are different output devices? We have display, that means monitor. We have speakers, we have printers. And what are memories there which have stored the program? We can use, there is a hard disk, there is a RAM and there is a ROM, which you have seen in your mobile also. When you purchase mobile, what thing you check first? You check, yeah, how much ROM is there. The first thing you check in your mobile, what is the capacity of ROM in my mobile? Oh, it is 128 GB. GB is a unit which defines the memory. Oh, it's 128 GB. It's good. I can store songs, videos, and different things in my mobile. Similarly, we have a computer which is defined by memory and by operating speed. How fast a system is operating the program or executing a program. Same thing happens with our brain also. There are 5 students and same question is given to them. When they work on a question. So what they do, different students execute or solve the problem with a different speed. That means everybody have their operating speed and different age people. Let's say a student of 8th class, if you compare with 12th class student, then their operating speed or execution speed will be different. Now, coming back to my Arduino board. What Arduino board I am using here? I am using here Arduino Uno. So when we define Arduino Uno, how we define it? We define it with inputs and outputs. How many inputs are there and how many outputs are there? As you are seeing on screen, we have Arduino Uno. So as you are seeing, there are pins starting from 0, 1, 2, 3 up to 13. We have pins on the bottom side A0, A1, A2, A3, A4, A5. Apart from them, we have power pins 5 volt, 3.3 volt, ground and Vin. To drive this Arduino board, we input or we supply it with a potential with a battery of minimum 5 volt to 12, maximum 15 volt. But I recommend you to apply 12 volt, maximum 12 volt. Internally, Rehan, write it there. Internally, microcontrollers or your Arduino board use 5 volt DC power supply. Internally, Arduino use 5 volt power supply. Don't get confused. Don't think that these things are moving over my head, because these things are this is totally new. Just think keep one thing in your mind. We used to feed it by a battery, external battery that can be 5 volt up to 12 volt, and we can program it using USB cable. So you can plug it as you are seeing here. I have a Arduino Nano here. I have a cable here, USB cable. I am connecting it like this. So like this you can program it. If you are not using any external battery, you can feed it by the USB cable also. But it is difficult to carry your laptop with the Arduino board every time. In that case, we need to feed this Arduino board by an external power supply. So you have different inputs and outputs, pins, where you will be feeding or where you will be sending your signal. So why we are using Arduino board? So that we can program it. We will send the signal status to the controller, and based on the program in the controller, we can operate different devices. So for that we need to know what are inputs, what are outputs. As we have seen in our body, or we have seen in our computer, there are input devices which is sending the signal. If I am feeling some pressure in my body, automatically one signal will be transmitted to my brain, and my body will try to retaliate, or will try to lose or avoid such circumstances by in the form of reacting or moving my hand away from that whatever that thing is happening at that particular place. Is Have you ever uh, felt it that you are feeling pain in your hand and you are touching your shoulder? Have you ever faced such type of things? Never. If you have feeling anything, any pain or any, if you feel if somebody is touching on your hand, you will only see your hand only. But that means your total concentration will be then direct to your hand only, because you have felt that something is happening in your hand. You will never see that where I am feeling, or where the person is touching who is touching your body at what place. If let's say I am touching your head, your hand will automatically go to your head only. Mean to say that our full body is fitted with sensors everywhere. Doesn't matter whether you feel heat, you feel pressure, whether you feel a jerk, whatever. So in our Arduino, what we are doing, we are giving inputs to the input pins. And what are those pins? 0 to 13 are our input pins and output pins. That means we can use these pins as inputs and outputs. But these at this particular moment, one more question came here. Let me take you to another example first. I'm moving back. Let's first take another example. And that is, I have interfaced again one LED, but now I have used one switch here. So I'm opening it. So here what I have done, I have used one Arduino board. Again I have used one LED and a resistor. But now I will be operating this LED with the help of one switch. That means when I will press a switch, I want that my LED my LED glows whenever I press a switch. As you are seeing on the screen, I have used one switch at the input and I have connected one LED at the output. First let's take a look, let's take the simulation here. I am running a simulation. As you are seeing here, when I press the switch, my LED glows. If I release the button, my LED will get off. So on and off, on and off. So what I have done here, I am giving one input signal to controller, and when controller will sense that signal, automatically it will be glowing one LED. And now let's check the program also. So here what I have done, so here in this program I have used the condition. If my controller sense a condition, turn on the LED. Otherwise, turn off the LED or keep the LED in off state. So what is the condition here? If and else. Have you heard about if else condition? Have you heard about if else condition? Daily you use it. Daily you use it in your daily lives. So this is a controller here. If I press, this is my button. If I press, the LED will glow. Otherwise, it will remain off. So what I am doing, I am feeding the condition of this button to the controller, to the input, and based on that input and based on the program I have loaded here in this controller, my output will behave. What is my output? One LED. So whenever I am pressing this LED, this button, my LED is glowing. So what is this condition here? This condition is if and else. Many a time you have come with the situation when your mother says that beta go to market and bring curd. If you didn't, if you will not find the curd, bring milk. Are you getting this? So you have two situations. If you get the curd, or you can think into this way: if the dairy shop is open, bring curd; otherwise, return back. Are you getting? So condition is like this: go to market, bring. If the dairy shop is open, bring curd; otherwise, come back. Or you can think it in this way: if dairy shop is open, bring the curd. Or do, if it is closed, do another thing, or bring milk from another shop, from the general store. So such type of conditions happens daily in our life. If this, do that. If this, do that. If and else, or for loop, while loop, there are different type of conditions which we use. From my inputs, you can see here in input blocks, we have read digital pin, read analog pin. I'll tell you what is digital and analog also. So read digital. So what I have done, I have taken one read signal, which is connected to pin 2. You can see here that this is connected to pin 2, and I am comparing this with one equal sign, mean to say, if we are sensing a high on digital pin 2, then turn on the LED. We are using another command, output command, set pin number 12, because we have connected our LED to pin number 12. So what we are doing, if read digital pin, which is 2, is high, turn on the LED which is connected to pin number 12. Otherwise, or else, keep the LED low. So when I press the start simulation button, same, whatever I have written there, it is happening there on the screen in the simulation. If I press the button, it is saying if something high means that signal is there, low means signal is not there. When I press the button, signal is transmitted to pin number 2. So when at 2, controller will sense the signal, and what in the programming I have written, that if it is high, set the pin 12 high. That means if it is high, it will make the LED high, or make the LED on. Otherwise, if I release the button, what will happen? LED will turn off. So this is simple program we have written to make the LED on and off. Now, at this particular moment, one more thing I would like to tell you, but before that, if you are getting things easily, please write in comment section. My team is there, which is there, who are there to help you. If you feel any confusion here, write in comment section. Uday Vasisht, Sanket Uday Vasisht?
Yes.
And Chetan Sharma. I really appreciate you both. You have done tremendous job. Whatever circuits we have given, you have finished them on time, replied them in a proper fashion, and you have even put so many queries related to circuits, genuine queries, and I feel really happy that you people are showing interest. And don't feel hesitated whenever you feel you want to know about you have any query, you have any confusion, or you are facing any problem in designing or making the circuits. Write in the comment section in our previous video. Now we have our session 1, which you have watched last week. Whatever queries you are having, whatever problems you are facing, please write in the comment section in that video. We'll revert back to you. Definitely we'll revert back to you and we'll help you out in your circuits, in your question, whatever question and queries are there. So this I am taking, I'm starting with a basic example so that it goes easy. You can understand it easily in a easy way, in a proper fashion. Don't think that these circuits are small or very easy. So just to make you aware, just to make things familiar to you, coding familiar to you, we are taking small examples. So in this example, what we have done, we have used one condition block here. Now I am also showing you the code also. As you are seeing on the screen, if there are two sections in the program. One is setup section and another is loop section. So these are functions. What is setup? Setup is used to define the initial environment, to define initial conditions. What are initial conditions? We need to define the Arduino's pins, that which pin will be used as input and which pin will be used as output. As I told you that we can use the pins as inputs and outputs starting from 0 to 13. So we can use them inputs and output also. There are other things also, but I will not tell you now. In next session, we will be discussing about another options also which are there, which we can do with these pins. But at this particular moment, right now I'll tell you that we can use these pins as inputs and outputs. But we need to define them. By default, all the pins are considered as input pins. But if we want to use any pin as output, we need to tell the controller that I am going to use this pin as output. So to define these things, baud rate is also there. We'll define it. I'll tell you in next session. So baud rate is a speed to transmit the signal. So baud rate, pins. So to define the initial environment, we use setup pin. It is something like this, that let's say you are playing a game. So what do? First you define that you will be in team A, you will be in team B, you will do this, you will do bowling, you will do wicket keeping. Let's say if we talk about cricket, you will do wicket keeping. So what you are doing? You are setting the environment. What you are doing? You are setting the environment before moving further. Then the next section is the loop section. What is loop? In loop, we run the certain instructions a number of time or to infinite time. Sometime what we do, we define the loop environment. What we do, we loop the loop condition. Let's say I will be doing a task for 10 times only, 100 times only, or 50 times only. So that is one condition. You are defining a loop. Or you can define a loop with unlimited loops, which is happening here. What is happening here? That we have defined a loop for infinite time. We haven't put any condition here. If the condition is true, that means if the input is there, output will glow. So we have put this in this loop. Same thing happened in our previous example, LED blinking. What we have done there, we are blinking the LED for infinite time. When the Arduino will start, LED will keep on blinking until the board is powered. If board will not be powered, it will not execute the program and your LED will not glow. So loop will be continuously keep on running, keep on blinking the LED. So that loop is up to unlimited time. So these two sections are there where we have defined in setup pin mode, pin 2 as input, pin 12 as output, and in loop we have set a condition: if we sense digital 2 high, make digital pin 12 high, otherwise or else keep digital pin 12 low. So this is the code where we have seen the block also and the traditional code also. And what we are doing here, we are blowing the LED based on the condition we are inputting from input side. Okay. Please keep the notebook handy, keep noting all the points you are listening here, because when we don't note, we feel that we are smart, and afterward, after the session and after 1 or 2 days or after a week, we forgot things, and then that creates confusion in our understanding. Sir, when will we share our projects? In our next session, we'll be doing more projects based on Arduino. And in next session also, we'll allot you the project. Simple circuit and Arduino project. And on the final day, we'll be performing one project for you on Tinkercad only. Whatever projects will be allotted, that project you will be submitting on the 5th session. We'll announce that too. So whatever projects will be allotted will be given to you. You need to submit it before the end of after the end of 4th session. So Tyrannosaurus, I think that things are clear to you now. Okay. So now we have got an idea that how we code a system. That means Arduino board. And doesn't matter whether it's Arduino board, whether it's your computer, whether you are designing a website, whether you are making a game or an application, Android application or iOS application, logics will remain same. Once you got the logic, things will get easy for you, because when we get the idea that how to code a system, then you can code anything. Okay. Now next I would like to show you this, which is called as flowchart, which is the main thing while before programming or before making anything in your life. That means we need to make a plan before moving further. If you are running a business, if you are planning to run a business, what do? You make a plan that what are the things and how you are going to execute different strategies in your business. In the same way, when you start from your house for a particular task, you make a roadmap in your mind that how you are going to implement your today's task. Mean to say, you think that first I'll go to market, from there I'll purchase this. If things will not get if I'll not get the things from the market, I'll move to another market, and then I'll move to my coaching or tuitions. Then after finishing there, I'll again move to the general store. I'll purchase kites. Then you will move again back to your house. Then you will fly the kite in your spare time. So this is what you have made a plan. You have made a roadmap. Same thing we need to do when we program. That is called as flowchart. How we define a flowchart? The oval shape is used to define the start and end of the program. And this rectangular shape is used to define the task which you are performing. This is very basic flowchart. Just because it can be more complex, but I don't want to make you confused here. Simply try to understand it. Then we have triangular, this square shape in a triangular form to triangular form, which is used to define the condition, and then this arrow is used to link these different sections there in the flowchart. Let's say today your plan is to buy a kite. What do? You will start and you will take the money. What will be your next step? You will see, is shop open? You will find that is shop open. Then there will be two conditions in front of you. Maybe shop is open or not. So let's say shop is closed. So what you will do? You will find another shop, another shop, another shop. Until you get your kite, you will keep on searching for a shop. Then after that, after finding the kite, after finding the shop, you will purchase the kite, and after that you will end your task. This is your simple task. This is the simple example I have put in front of you. You can take any example. Tea making, whatever task you are doing in your daily lives, whatever tasks you do according to this flow chart only. Conditions are there. Have you ever done anything where you have completed the task without any condition? That means whenever you do a task, most most of the cases you find you implement conditions there, 2 or 3 or 4, or sometimes you simply complete the task and come back to your initial position. So same thing we use in your programming also. So when you program, start to make your program, first you need to make your flow chart. What benefit we get? Things become easy for us to code our project. Then again moving to my project here, which is an Arduino. An LED is connected, pin number 12. I am connecting this to pin number 12. What I have done here, I have made this pin number 12 as output pin. And what is the type of this pin? Digital pin. Then I have taken one switch, and then I have connected that switch to pin number terminal 2 to pin number 2. So I have connected it to pin number 2, which is also digital pin. But what is pin number 2? I have defined input pin. What I am sending a signal, 5-volt signal. As Mr. Sanket was saying in the comment section, that internally Arduino boards operate at 5 volt. Whenever it sends 5 volt, it will be high for Arduino board. Whenever it will be sensing 0 volt, it will be low for Arduino board. So 0 volt as low logic or low level, and 5 volt as high level. So what I have to do, I have to apply a 5 volt DC signal taking from the board itself through the key, through the switch to input pin 2. So when this switch is what? Switch is opening and closing. Actually it is making the connection or disconnecting the connection. So this 5 volt coming from board, moving through the wire, passing through the switch and moving back to pin number 2. So whenever there will be 5 volt, automatically controller will sense that there is high at pin number 2. And what controller will do in this situation? It will glow the LED based on the program. What we have done in the program, if it is high, LED will glow. But what is digital signal? What is digital? This is the big question in front of you. What is digital signal? And what is analog signal? Have you heard about analog signal? I am giving 10 seconds of break here so that you can comment here, because this is very important question. What is digital signal and what is analog signal? Yash Prahlad Valvekar, how many circuit design softwares are there? You can make on Fritzing, you can make it on Circuito.io. Even on Circuito.io, we have a benefit that you simply need to drag and drop the components. Automatically, it will make the circuit by itself. You don't have to you don't have to scratch your head. You will get the idea that how to connect different components, different devices, different sensors with your Arduino boards. So Circuito.io is one of the tool where you can make your circuits, and then you can have fritzing, but that is not simulation. You can use uh, Sanket, which one? Proteus. You can make on Proteus also. But for simulation, Circuito.io and this Tinkercad is there. But if you have hardware, if you have this hardware with you, if you, let's say you have breadboard, you have components and everything, you can check the circuit on Circuito.io. Connect the components according to the circuit shown in this on over there, and then you can check it there on the board. But for simulation, what I think that for basic circuits, this Tinkercad is good, is amazing tool. Digital and analog signal. Okay, what type of signal I am giving to glow this LED? Digital or analog? Okay. So digital signal, one of the educational learner, good, you have given one answer there. Digital signal is a signal which is displayed on screen. Okay, let me show you. Let me show you what is digital and what is analog. You can see there on the screen, I have made a square shape waveform on the top side, which I have mentioned digital signal. And on the bottom side, I have drawn a graph, random graph, and one sinusoidal graph. So what is digital signal? Whenever there is a situation or condition where there are only two situations, yes or no, true or false, high or low, 5 volt or 0 volt. There is not if and there is not if or else or this or that or that. Only two conditions are there. Fixed, on, off, or you can say false, true, low or high, 0 or 5 volt. And one of the best example I would like to tell you here is your simple switch in your house. When you turn on your light, what do? You simply turn it on or turn it off. Is there anything else other than that? No, there's not any other position in the switch. There are only two positions, on and off. True or false, high or low, 5 volt or 0 volt. So what is digital? Digital signals are signals which are based on only two conditions. And most of the situations we come through are digital signals only. Are you getting me what I'm saying? Where there are only two conditions. When we talk it electrically, in computers or in digital in our circuitries, Arduino circuitry or your computer or your controller, we define them by 0 volt and 5 volt. Or sometimes you might have heard logic 0 and logic 1. Logic 1 is actually a name given to 0 volt. When a controller will sense 0 volt, it will interpret it as logic 0. And whenever it will sense 5 volt, it will interpret as logic 1. In programming, we sometimes say it logic high or logic low. Sometimes we also define as true and false. So these are different names, but they all are telling us that there are only two situations. So as you are seeing on the screen, we have here 5 volt continuously. then it will go low for some time, then it will go high, then low, then high, then low. So what is happening here? Let's say blinking is there. What is happening in LED blinking? LED is high for a particular time, then low for a particular time, then high for a particular time, then low. So what is happening? It is actually making things in this fashion, that it is making our LED as LED is low, then high, then low for a particular moment. Let's say for 1 second it is high, and for 1 second it is low. So one for high, one for low, one for high, one for low. You can make it high for 1 second, or let's say you want to make it low for half second. That is also possible. One for high, half for second. Or you can do it like this: for 5 seconds LED will remain high, for 1 second LED will remain low. But what is happening here? Whatever be the repetition, or whatever be the interval in high and low, the condition remains true or false, or high or low. There is nothing in between. Are you getting? So high and low means we have a signal which have only two states. And what is switch? What that switch I have used, that is a digital signal, that is giving digital signal, because switch will only send as 0. If it is, if the switch is not connected, it will send 0 signal. If it is connected, it will send 5 volt or high signal. Now what is analog signal? And have you used analog signal in our previous session? Have we shown you any example of analog signal in our previous session? In analog, what is analog? Analog means which keeps on changing with time. Let's say temperature. If we measure whole day temperature, if it will keep on changing with time. Amplitude means, let's say the maximum signal reach up to 10 volt, from 0 volt to 10 volt. So the signal will be keep on happening, or you can say 0 to 5 volt. But it will not be 0 or it will not be 5. It will be varying between these two values, 0 to 1 to 2 to then 1.5. So the signal is changing. In assume a temperature signal. Temperature is 20 degrees Celsius, 20.2, 20.5, 21, then 20.8. So whenever signals are changing, those signals are called analog signals. And what is that? The pot you use in your fan. What do you do by that regulator which is fitted in your fan? You regulate the power voltage. You operate the fan at different speed. So whenever we need to operate a system or thing at different speed, we use analog signal. Whenever we need a variation in the signal, then automatically at that particular, in that particular situation, you need analog signal. I'm moving to another circuit where I will show you how to use analog signal. Students, maybe you are feeling that it is a little bit boring that I am telling you about analog and digital signal, but believe me, to get proper understanding of controller, you need to have the knowledge of all these things. Otherwise, you will keep on, the things will be confusing for you. Again and again you will scratch your head, you will be seeing here and there, you will be asking different people, help me to design my project please. So to get proper understanding about the controller and interfacing, you need to have all this, you need to know all these things. Our next project is interfacing of LED again, but now what we have done here, we have used one potentiometer here. RGB LED? Okay. Okay. Briefly, I'm just showing you one RGB LED project here, where we have one LED which will be changing its color to red, green and blue. do it yourself. We'll share the circuit diagram with you, and I'm showing it on screen also. We'll share it. We are running out of time, so we'll share it. But what is happening here? This LED is glowing red, green, and blue. RGB LED. So single LED can be used for three different colors. You can mix them by changing the intensity of these three terminals. It is 4-terminal LED, so you can changing the potential at these three terminals. You can change the color also. As you are seeing on screen, I have RGB LED, and I have connected this LED with three different switches. If I press first one, it will glow red. If I press second one, it will glow blue. If I press third one, it will glow in green. And if I press two buttons, let's say green and blue, you will find that the color will change, because when we mix two different colors, it will give us different color. You can check it on internet, or if we mix green and blue, what will be the color. Then we have added all the colors, red, blue, and green. What color we are getting? White color. So in this way you can connect these three different this LED with the three different switches, and you can check the combination of color, and you can check the program also. We'll send you the program also. You can see here, as you're seeing on the right side of the pen, this is the program here. What we are doing here, if we sense the signal on pin 2, glow it red, then green, then blue. We'll share this program also, don't worry. But now moving to our next program, which is based on potentiometer. I have told you to learn about potentiometer in our previous session. What is potentiometer? Potentiometer is nothing but a voltage divider, or think it in this way: a potentiometer is nothing but a variable resistance, where you can change the resistance by rotating the knob. When you are rotating a knob from 0 ohm up to maximum ohm, you can change the resistance. So it is having three terminals. So between two terminals, I'll show you. This is the potentiometer internal diagram, where you have a potentiometer. It is having three terminal. 1, 2, 3. 1 and 3 will be connected to the potential. Let's say we are applying 5 volt. So 1 and 3 will be connected to 5 volt. And the middle one, the middle one will be used to take out the potential, because as you are seeing here on the screen, we have 1 and 2, and third is a wiper, a slider, which will be moving from 0 position to maximum position. Let's say 3 is at initial position over here. So when 3 is at initial position, let's say this is our variable resistance. This is pin number 1, this is pin number 2, and this is the slider, pin number 3. If it is at this position, what will be the value of resistance? 0 ohm. And when we keep on moving the the wiper or the slider on this resistance, the resistance will keep on increasing, and at this point it will be maximum. Let's say we have a resistance of 10 kilo ohm. 10 kilo ohm means 10,000 ohms. So what will be value over here? 0 ohm. And when you will move to the maximum position over here, or you can see on screen if it is not visible to you, at this point towards the pin 2, it will be having maximum resistance. So by the help of this potentiometer, what we will do, we'll be rotating this. This is the potentiometer, and I am rotating this clockwise and anti-clockwise. What will be happening? By rotating this potentiometer, I am changing the resistance of the circuit or potentiometer. So now let's check it there. Let's check it here first on the simulation here. If I run the simulation, now LED is at is not glowing at this particular moment, I am increasing the potential. And as you are seeing on screen, the intensity of or the luminosity of the LED is increasing from minimum to maximum. You can see if I am bringing back to its initial position, again LED is off, and when I start it again rotating it in clockwise, LED is glowing and intensity is increasing, luminosity is increasing and increasing. What is the value of this potentiometer? 10 kilo ohm. You can change it. You can change the potentiometer. What will happen if potentiometer value will decrease? The intensity of LED will increase. So what I am doing here, I am changing the resistance by the help of potentiometer to increase the luminosity, to increase the intensity of LED. Now this is the working. You can see here also on my board also. You can see on the on this board. This is the potentiometer. If I change this, the intensity is increasing. I am changing the potentiometer value and the intensity is increasing up to maximum. So now this is an example of analog signal. Now what we are doing, in the previous case we were feeding or we were sending the signal to the input with the help of a switch which was having only two conditions, either on or off. But here in this situation, in this potentiometer, we are not giving a specific signal 0 volt or 5 volt. What we are doing, we are changing the potential of voltage from 0 volt to maximum 5 volt. And how it is happening? With the help of this variable or this potentiometer. Now to feed the analog signals on our analog board, we have separate pins which we use to define them with the name of A0, A1, A2, A3, A4 and A5. So these 6 pins, analog pins starting from A node to A5 are used to feed to input analog signals. So whenever you need to input analog signal to the controller, you need to input signal through these pins. There are other tasks also which we can perform using these pins, but today we will not be discussing them. But consider them as analog signals, A0 to A5. So now moving to the project. On our project, what we have done here, you can see on the breadboard that we have connected pin number 1 of the potentiometer to ground. Okay, one more thing here. Ground, sometimes 0 volt is also referred as ground. So 0 volt and ground both are same. So what we have done, we have connected pin 1 of potentiometer to ground of the controller and pin 2 of the controller to 5 volt. As I told you that pin 1 need to be connected to 0 volt and pin 2 need to be connected to 5 volt. What about pin 3? Pin 3 will give us variable potential. Where we will be applying that pin 3? We'll be applying that pin 3 to A node. As you are seeing here on the screen, I am going to new project. As you are seeing on the screen, I have connected this pin 3 to A node pin of Arduino because this is analog pin. So I have connected to pin A node to input our signal. Now to connect our output with that, which is LED, we have used our digital pin 3, which is used as output pin, and we have connected our digital pin 3 anode positive pin to pin number 3, and pin number cathode pin we have connected to ground or 0 volt. So this is connected to 0 volt and then anode is connected to pin number 3, or you can say to output pin. Now moving to the programming part, how we have programmed it. As you are seeing it, we have this instruction here in front of us. What we have done here, we have set pin 3 to pin A node. That means whatever value will be there on A node, this is there, which we have given here in this condition. Sorry. So this is there. I have made this condition here and I am comparing these two conditions. Sorry. Sorry, I am making this condition like this. So what is there? That I have used one block, a set pin block. Set means turn the LED or make the output pin 3. I have chosen pin number 3 according to the condition which we are reading on pin number A node. So whatever be the condition or whatever be the value at pin A node or analog pin A0 will be transferred to output pin 3. And what we are doing before moving the signal to pin number 3, we are dividing the value we are reading on pin A node by 4. Why we are doing this? We'll discuss it in next session, in our third session. Don't worry. Think it in this way. Forgot about this divide portion, divide by 4. Think it in this way, that whatever value we are sensing on input pin A node, analog pin A node, is transferred directly to pin number 3, because pin number 3 is output pin and that is connected to to LED. Now let's imagine this with the help of potentiometer. Let's say we have given 1 volt. So the controller has read 1 volt. So what controller will do? It will transfer 1 volt directly to output, which is connected to pin number 3. Now pin number 3 is also an output, but analog output. What is that output? Analog output. Because we are feeding analog input, so we need analog output. We don't need analog in digital output. So we are varying the potential 1 volt, 2 volt, 3 volt, 4 volt, 5 volt. So let's say at analog A0 it is 1 volt. So 1 volt will be transferred to pin number 3. So correspondingly or with the same potential, LED will glow. Then we make by our potentiometer. Let's say with the help of this potentiometer, we have made it 2 volt. Then 2 volt will be transferred to output pin 3. Then we make 3 volt. 3 volt will be transferred to pin number 3. Then we make 4 volt. 4 volt will be transferred to pin number 3, and so on. So now variation in input, which is fed to A node analog, is transferred to analog output pin number 3. And because of that only, our LED intensity or LED luminosity is changing. Why this is happening? This is happening because we have connected our potentiometer or analog input to analog pin 0. So you can interface temperature sensor here. LDR we have used in our last class. LDR also, when the intensity will keep on increasing, LDR resistance will keep on reducing. So variation is there. So LDR you can use as digitally or analog also. So whatever based on the intensity or the intensity of light, the LDR sensor will keep on changing the resistance. So analog sensors are used, or analog conditions are used wherever we used to operate a system at different speed with different conditions. Let's say you want to run your fan with different speed based on temperature. Let's say you want to run your fan with full speed at 28 degrees Celsius. You want to run your fan at minimum speed at 20 degrees Celsius, or at half speed at 25 degrees Celsius. In the similar way, let's say we have a motor which is used to stir milk. Let's say motor stirrer, or you can say you have a washing machine. You want to run your washing machine at different speed. You want your washing machine to run at full speed if your washing machine is half filled. If your washing machine is full filled, you want to run your washing machine motor at half speed. So there are variety of conditions there, variety of applications there in the market where you want to run your system at different with different speed, with different uh, conditions. Okay. So is it clear to you? Are things enjoyable here or not? Are you enjoying the session or not? Maybe things, maybe you are feeling that some of the things are very difficult for you people. You are actually learning engineering. So you can imagine how difficult is engineering. But with the help of this simulation and this visual programming, I don't think so that things are that difficult how the way it seems. Am I right? Okay, okay, okay. So we have seen analog sensor also. If we move to the text, the simple code here, you can see we have defined in the setup input pin, analog pin A0, and pin number 3 as output. And in loop we are reading analog sensor which is connected to pin number A0 and writing it on pin number 3. So whatever we are taking from pin number from A0, we are writing the same content on pin number 3. If some, let's say you are rotating a speed, you are controlling a fan and you are checking the speed. One person is saying you make the speed half, so you are making the speed half, and make the speed full, you are making the speed full. Okay, we are running out of time. Now moving to one more example. We are extremely sorry. Things are taking time to cover. If you are enjoying, please write in comment section. If I can continue the session for 15 more minutes, please write in comment section. Send करने and please I request you all, please, whatever circuits we have sent to you on your WhatsApp numbers, please finish those circuits and revert back, send them back on the WhatsApp number. And please, if you have any confusion, if you want to know anything about previous session, write in comment section of that video on YouTube. And please subscribe the channel and write in the comment section in our previous session. Okay. Yes, sir. Yes, I am enjoying. Lakshmi Narayan Shastri, Suraj Goswami, Shinoy, Mariam, educational learner, Suraj Goswami. We have amazing audience here. We have really young innovators. This is really, I highly appreciate your efforts, and really I'm happy to see that you people are enjoying this session. Okay. Yes, Azure Dragon, Suraj Goswami. Good. Okay. So this will be our last circuit for today's session. Okay. What you are seeing here, we have one passive infrared sensor which we have used in our previous session also with simple circuitry. We have one LED here, and two basic components are there. What are basic components? Resistance, in order to make the circuit workable, because to limit the current and to protect our components, we need to fix or we need to use these resistance with the proper values. So this LED resistor is 120 ohm and this resistance R1 is of 10 kilo ohm. Okay. Since PIR sensor is a sensor, so need to be connected at input, and this PIR sensor will be working as digital sensor because it will not give us variable varying signal. It will give us high and low. As I told you, whenever we will be there in the proximity of this proximity sensor, it will detect and it will send a signal. And what is that pin? By pin number 3, it will be sending a signal to our uh, controller, to our Arduino board. So it will be working as a digital signal. And if motion, let's say we are in the proximity of PIR sensor, but we are not doing any motion, or the object is stable or still in at that position, it will not give signal. PIR sensor will give signal only if the object is moving, is in unstable condition, and is in proximity in the range of that sensor. So first we'll see the working operation. I'm starting this simulation. Now I'm here. Let me make it a little bit smaller. Okay. Okay. As you are seeing, my object is there and it is in the proximity. This is the proximity marked by this shaded area, but it's not giving any signal to the controller. Whenever there will be any movement, look, LED will glow. Whenever will be any movement, automatically LED will glow. So what is happening? Passive infrared sensor, this PIR sensor is sending signal to Arduino, and based on the program we have written in this controller, the controller is giving signal at the output. And what is the output device here? An LED, one LED, sorry. So I'm moving, LED is glowing. If this is stable, not moving, or still, LED will not glow. I believe you have got the idea. Now let's see the program also. Now moving to programming part. What I have done here, again we have a condition. If we sense a high signal at pin number 3. Why pin number 3? Because pin number 3 is input pin, digital input pin, and connected to passive infrared signal, because passive infrared signal is sending a signal to pin number 3. So whenever we are sensing a high at pin number 3, what we have to do? We need to glow LED. Are you getting? So whenever there is high at pin number 3, LED will glow. Otherwise, if it is not high, otherwise what we have to do? We need to keep LED in low state or off state. So let's check the program. If read digital pin, which is 3, is equals to high, then make the pin 6, which is output pin 6, connected to LED, high. Otherwise or else keep the pin number 6 low. And what is low? 0 volt. And what is high? 5 volt, according to Arduino board. And most of the board, doesn't matter whether your computer board, your mobile board, all the circuitry, digital circuitry operates between 3 to 5 volt. Externally you may be giving them 12 volt, 5 volt, 24 volt, but internally inside the board use a potential level, a voltage level of 5 volt. So this is simple circuit, simple program where we have used a block, if and else block, put a condition here, choosing from the condition control pin. Here you can find the conditions here. repeat 10 times, repeat while we have a certain condition, if and then, and if and then else. Okay, if we use if and then, what will happen here? Let me take this condition here. If we use if and then, what will happen? The LED will keep on glowing. Once the controller will sense high, it will glow LED up to infinite time. That means until the board is powered. So what is the benefit of using, if you need to off the LED, if the condition is not true? What is that condition? If we are not getting high, if that is not true, and in that condition if you make the LED low, then we need to use if else condition. Otherwise you can use if and then block in place of if else, isn't it? Now moving to the code also. Text code. What is there in text code? Again, two sections are there. Setup, where we have first set pin number 3 as digital input, and where we have fixed pin number 6 as digital output. So we have set initial environment, then we'll be moving in loop. What is there? If digital pin 3 is reading or is equals to high, write or make digital pin 6, which is output, high. Otherwise or else keep digital pin 6 in low state or at 0 state. So this condition will keep on running. Once you will load this program, upload this program on your controller with the help of USB cable. This is what the USB cable. So once you will be uploading your program with the help of this USB cable, and if your board is powered, the controller will keep on working based on the sensor you have interfaced here. So these are very basic programs we taught you to make things easy, and you can connect LED or sorry, different controller actuators also, motors, displays, or anything else in place of this LED. But we don't want to make things messy or confusing. That's why for today's session we have kept the things in this fashion, in this in this easy way. I hope you have understood all the concepts, and I want to repeat the things we have covered here. What we have covered here, we have seen that we have the varieties of Arduino boards from Arduino family, and we thank Arduino family for giving this amazing technology to us for free. We can use them for commercial and non-commercial use. You can use them anywhere. Even you can use their hardware also. They provide their hardware circuitry also, everything they provide. Then we have seen the comparison between human architecture and human working, and human architecture and computer architecture, where we have input and output connected with CPU and memory. Then we have seen flow chart, or how the roadmap we make for our programs. Then we have seen Arduino Uno board, its pin configuration. We have ground, which is used to define 0 volt and 5 volt. We have digital pins 0 to 13. We have analog pins A0 to A15. These 0 to 13 pins can be used for different purposes. Digital, analog. We'll be discussing analog pins in next section. Then we have shown you digital signals, which are zeros and 5 volts, or low or high, maybe at different intervals. We have shown you analog. Now you need to work on binary numbers. What are binary numbers? Sanket, please write in comment section binary numbers. Please do a little work on binary numbers. Binary numbers. What are binary numbers? And next section we will be covering what is binary number. But from your side, please do one thing. Take a look on briefly on different on binary numbers and their patterns. Then we have seen, sorry, this is LED on, LED off, high and low. These are different switches here. Then we have seen potentiometer, which is used for voltage divider, or in simple way we can say we can choose variable resistance with the help of potentiometer. This will be discussed in next lecture. So these are the things we have covered in our today's session. Then we'll be giving you more examples. Maybe Mr. Rehan or Mr. Sanket, they will be sending you these circuits. I'm showing you one by one on screen. This is the circuit where we have used 3 potentiometers to to control the brightness or to mix the colors red, green and blue with the help of these 3 potentiometers. Then we have another circuit for you will be sending, which is based on LDR, light detecting resistor. This will be sensing the intensity of light, and based on the intensity will be changing the luminosity of this LED. Then we have another circuit of LED which I have covered briefly, this RGB LED. Then one more sensor, one more is there, which is based on tilt sensor. Tilt, have you heard about tilt sensor? Tilt sensor is used whenever you want to check the tilt. Let's say you have put it on the table and you want to make the table aligned to the ground, and if you want to check uh, that whether your table has tilted or not, or your bicycle, if you want to check whether your cycle is aligned or standing in aligned to the ground, you can fix the tilt sensor on the surface, on the top of the cycle surface, and you can check the tilt. Whenever there will be tilt in the cycle, your LED will glow. Sorry, your actuator will glow, will actuate. So you can use in your cycle, on table, in different applications. And I request you all, please, whatever queries you are having, this video will be there online after 30 minutes. Please write into the comment sections. Motivate us with your comments, writing in the comment section of the videos, and I will be happy to see you if you can send your selfies working on your Tinkercad. Take a selfie with, let's say, with this tilt sensor and on your computer, and send the selfie on our WhatsApp number. We'll be very happy. Please do this for us. All of you, sit in front of your computer or mobile, take a selfie with this tilt sensor or with RGB LED or with PIR sensor, and send this selfie to our WhatsApp number. Okay, so first session link is in the video description. So please go to the first session video, to the video of our first session. Whatever comment is there, write into the comment section. ये कौन सा सेशन तुम डाल देंगे? Okay, link is there in the video description. You can check it there. So you can go there and write your comments there. Motivate us with your comments. We'll be there again for you in next session, and with more amazing circuits based on Arduino. And we are planning to introduce more sensors, interfacing of more sensors and motors, different type of motors in our next session. And we'll be we'll be explaining you more about visual programming. So thanks for joining in, all of you. Welcome again to the family of young innovators. I again appreciate you for your efforts, for your comments, for your circuits you have made, you have practiced, and you have sent to us. Again, thank to Uday Vasisht and Chetan Sharma. And I request all of you, please send and complete the circuits and send them on our WhatsApp number. Okay, see you then in our next session. Thank you. Goodbye.